Hello. Yes, you can hear me. Yes.
Hello.
So
That's good.
be
Yeah.
from this side. So today we have a presentation made by us. So regarding the strategic role of uh, agency, independent inspection agency, to mitigate the project issues in nuclear. So it's quite ambitious. So to present this, we are, as you see in the picture, we are almost same. So I'm Nicolas Pierredon. I'm expert in nuclear code since many years, in particular with AFCEN French nuclear construction codes, and Manish Waghare.
Yes. So my name is Manish Waghare, and I am basically the director of ASME services for Apave. I'm based in Houston, Texas. Thank you.
So we will try to treat this topic today, but even if it's difficult, maybe long and not complete, do not hesitate to go to our booth and discuss any topics you want. We will try to introduce a little bit the context and the stakes about this issue. Some reminder very quickly about RCC code and ASME code. Uh, Also some information about the AIA catalyst for ASME and RCC-M code compliance. Some aspect about QA/QC because we are involved in many activities related to QA/QC and not only on regulatory issues. And the strategic impact about the AIA on project risk mitigation. So just the introduction of the context. So in the world, we have some changes regarding the way we decarbonize the energy field. So in particular in USA, in Europe, in Asia, and in particular in Eastern Europe, we have a development of politics in order to create more nuclear power plants to decarbonize the energy produced in these countries. Of course, we are talking about EPR, AP1000, and SMR, and Advanced Modular Reactor that we call AMR, that they are linked to Gen 4 reactors. The workforce challenge is double because for established nuclear nation, as in France, or in France we work in nuclear, we are a nuclear fleet since more than 40 years. Of course, we have a lot of experts and technicians, engineers working in nuclear since many years. For a part of them, they participate to the construction of the actual, the working nuclear power plant fleets, but they are going to be retired soon. So in France today, we are about 200,000 people working in nuclear, and we need 100,000 people within 10 years, more. So for the workforce challenge in France and established nuclear nation, so it's the way we will create a new generation of workers in nuclear. For new entrants countries, as for example in Poland, that they start from scratch, no one is working in nuclear, and they need to build a new fleet. So they need to create from scratch a new generation of nuclear workers. And the vulnerability is related to the expertise and the level of expertise. Of course, we are working in a complex field. So nuclear construction code as ASME code or RCC code are complex. You need training, you need expertise. It's not made after 1 week of training, you are not expert in RCC code. So you need much more time to understand, also to understand the regulation associated with those codes. So it takes time, and of course, the independent body can help you to integrate such requirements, such expertise. So this context elevates the Authorized Inspection Agency and independent body, as we said, in France and in Europe, to a critical strategic partner for project success and risk mitigation. So we have a triple challenge and nuclear project, cost control, schedule adherence, and absolute nuclear safety as usual. So challenge accepted. So now some boring reminder about construction codes. Okay. So it will not be so long, but maybe boring. I'm sorry for that. So it is a summary that the fact we are working with two different worlds. So one is from the United States. Of course, it's a summary, it's not, we don't have all the details, but you can understand that from United States, we have a special standard developed, so ASTM as standards, and ASME code as a construction code. So a construction code gives a rule from design to manufacturing. A standard is a detail about how to perform a welding qualification, what is a stainless steel plate, etc. So ASTM for details, ASME code for design and manufacturing. And in Europe, we have, of course, the ISO system, with all the ISO standards, the European standard, and the French construction code. So AFCEN codes. So AFCEN is the French Association for Developing Nuclear Construction Codes. So in fact, two different words that they are not working the same. Okay? It is not so different because we are talking about nuclear construction code, we are talking about equipment, etc. So it's always the same. We are not making pizza and French fries. We are working on nuclear pressure equipment in general. So these two codes represent maybe 99% of the code used in nuclear in the world. So you need to choose your code, American style or French style, European style. So very quickly, this is just the content of RCC-M. As you can see, there are three classifications. Class 1 is top level, so the reactor core, the first primary loop, and class 2, 3, etc. Of course, we are talking about material, we are talking about examination method, welding, fabrication, and other innovation in section 6. As you can see, and it will be explained by my colleagues about ASME code.
Yes, so this is the way ASME codes are organized. ASME boiler and pressure vessel code section, it's got total 13 sections, out of which 2 are dedicated to nuclear. Section 3 is for new construction of code items, and section 11 is for in-service inspection. So section 3 is further subdivided into different divisions. Subsection NCA covers general requirements, mainly for Division 1 and Division 2. Of course, there are some references of NCA you will find in Division 4 and Division 5 as well. But then we have appendices which give some supplementary technical information like forms to be used for certifying a core item and other things like that. Division 1 is again subdivided into 5 subsections. Subsection NB is for class 1 component. Then you have subsection NCD. Earlier it used to be 2 different subsections, NC and ND. They have combined it to cover class 2 and class 3 components. It's called subsection NCD. Then NE covers your class MC components, metallic containment components, NF for supports, and NG for core support. Division 2 is dedicated for concrete containments. Division 3 is for containment systems, basically for transportation of spent fuel and other stuff covering that. Division 4 is for fusion devices, which is a relatively new code. Division 5 is high temperature reactors. It covers SMRs as well. Then section 11 is divided into two, again, divisions, division 1 and division 2. Division 1 specifies rules for inspection during in-service. And division 2 is dedicated for basically risk mechanism, identifying the risks and mitigation strategies, reliability and integrity management and stuff like that. Thank you.
So now if we put the two organizations, so the RCC-M1 and the ASME code 1, we can see that it is almost the same. Almost the same for two main reasons. One is because we are talking about mechanical equipment, so pressure equipment. So of course we need material, we need examination method, we need classification of different equipment, etc., and support, everything we need to create from design to the end of manufacturing, everything related to a pressure equipment. Because mainly the reactors developed in the world are pressurized water reactors. So of course we are always managing pressure. So here we can see, so the first reason is because we are talking about the same equipment. And the second reason is that initially in France, the reactor, the first reactor created in France for commercial purpose were the 900 megawatt reactors, and they were made under license of Westinghouse. So initially they were made according to ASME. In 1980, in France, we create AFCEN, so the French Association for Nuclear Construction Code, and we not copy-paste, but we were a lot inspired from ASME code. Okay? So, of course, we have almost the same structure for these two main reasons. Okay? So, warning, ASME is from United States, RCC-M from France and mainly Europe. So, of course, we are close to regulation. ASME code is close, very close to the American regulation. And of course, RCC-M is very close to the French and European regulation. Easier to use a French code in France than a French code in United States because it will be, there is no link with the local regulation. Nevertheless, a technical construction code, a construction code is made to manage the regulation and to manage the contractual relation between the different actors. And in general, you apply a construction code if you want or another one, and you need to demonstrate the compliance with the regulation. Something about the hierarchy of norm very quickly. We are talking about norm in general, not a standard, or we talk about norm in the sense of all type of document you can use. Very quickly, I'll show you the general organization in France in particular and in Europe. So of course you have the law, the regulation. So in France, the regulation is only decree and order. We call that right. And then the non-constraining field is the construction code, standard, etc. So in fact, we can call non-constraining field contractual field. This is mandatory, this is not mandatory. Okay. If we look on the American system, and Manish can explain a little bit about that.
Yeah, so American system, the legislation is basically 4 tiers, and the order of precedence is as stated in this on the right-hand side. So on the top comes statutory laws. United States Parliament has passed laws like Atomic Energy Act. They stay on top. So in case of any conflict between two different documents, we know the order of precedence. So the law takes the top precedence. It overrules any other requirements which are conflicting with a particular subject. Then comes your regulatory laws, which are basically enforced by the regulators. These are basically specifying detailed requirements of complying to a law. An example is Code of Federal Regulations, 10 CFR 50. Then comes NRC decisions. NRC is a regulatory authority in US. They publish, a lot of material, giving you the rules and regulations and the requirements for particular aspects of the constructions. So they are followed by ASME code and requirements such as NQA. So ASME codes has been accepted as one of the means of fulfilling the regulations.
Ah, it's yours also.
Yes. So that was the higher level overview, the previous slide, and this slide gives you hierarchy of standards within ASME, boiler pressure vessel sections. So boiler pressure vessel code section is again divided into different aspects. Like there are some construction codes, there are some supporting codes. Laws and regulations always at the top. Then the code of construction requirements come next. The code of constructions are basically the codes that define the rules for design, manufacturing, inspection, etc. So these are basically the main codes that are to be used for complying the code. These construction codes, they give reference to other codes or other subsections for particular aspect. For example, section 5 is referred for NDT, section 9 is referred for welding. So, but there could be some requirements which are conflicting with this code. In that case, code of construction always takes precedence. And the last is the reference standards, which are basically dimensional standards like B16.5 or B16.9, B16.9 or 11. So these are the standards which are referenced within the construction code or sometimes the reference code. So they take the last precedence. Yeah. So next slide.
So we try to accelerate a little bit regarding this because time is running.
Yeah.
For
so
you.
yes. So the role of AIA basically goes beyond the code compliance. Of course, the primary duty of an AIA, Authorized Inspection Agency, is to make sure that the requirements of construction code are fulfilled and the item is fulfilling all the requirements so that it can be stamped with a particular code stamp. So we are referring it as an N stamp as an example. Of course, if I want to be technically correct, nowadays ASME has revised their terminology. It is called ASME certification mark with N designator. But popularly it is called as N stamp. So the role of AI is not only to make sure that the product complies with the regulation, but the involvement starts much before even you start the fabrication. AIA helps you in developing the quality system, laying out the foundation for all the code constructions, writing down the procedures and work instruction to ensure that the item produced using those procedures will meet all the applicable requirements of the code. So as normal, AI is involved before the starting of fabrication, during the fabrication, and at the final stage of completion, witnessing the final testing.
So regarding the absent vision, it's a little bit different. In fact, we are more focused on the independence only regarding the activity we have. So in French and in RCC-M code, and of course in the French regulation, the AIA doesn't exist. Okay, we are independent third party. We can call an agreed notified body, organisme habilité in French, or what you want. There is no stamp in RCC-M, so it's a little bit different than the ASME code that we normally ask a stamp. So no stamp requested. In fact, the project risk mitigation is made by independent body where we verify the compliance between the construction code, what is done in the real life, and if the requirements from the regulation are applied. Try to accelerate a little bit. Something very important to keep in mind. ASME in United States. It's related to regulatory requirement. In fact, if you look on the 10 CFR 50, you need to apply a quality system compliant with NQA1, and to apply ASME is right good, quite good. Of course, you apply NQA1, you have a N stamp in order to design and manufacture nuclear pressure equipment. If you are not in United States, you are not submitted to American regulation normally. So you are not in the United States, you are in Bulgaria, in Poland, everywhere. You are not linked with the American regulation. You have a national nuclear policy to be followed, your own regulation related to nuclear. Of course, if you are in Poland, for example, or in Czech Republic, of course, you apply the PED for pressure equipment because you are in Europe. So you are not so far from the French system because we apply the same European directive. We have a special one called ESPN in France. It's not the sports channel. It's Équipement sous pression nucléaire, nuclear pressure equipment in French. And this regulation is French, but it's PED++, in fact. So if you are not in United States and you apply the ASME code, you apply it as a technical reference. NQA1 and stamp are just non-mandatory. So you just need to comply with, but you don't need a formal certification. In France, we try, the AFCEN code try to apply the French regulation and the European one. No stamp needed in France and abroad. So if you are in Poland or everywhere, or in China, you can apply the RCC-M without any stamp. The French regulation in France is special. In fact, you just need to apply the French regulation. So you need to demonstrate with the agreed notified body that you fulfill all the regulatory requirement from the regulation. That's it. So you can apply the RCC-M code, you can apply the ASME code, you can apply the Japanese code, you can apply a Chinese code if you want. You just need to comply with the French regulation. There are no official recognition of any construction code in France. Try to accelerate a little bit. I'm sorry. About QA/QC, very interesting. Of course, in most of the nuclear projects, you need initial recognition, training, testing laboratory, certification, in all the way. Just as a reminder, the ISO 19443 is the quality standard linked with ISO 9001, including the safety culture and the supply chain. Okay? It's the European and international equivalent to NQA1 from ASME code. Okay? Of course, QA/QC, you can see testing, quality control, quality assurance, and quality management system. I accelerate a little bit. Very quickly, in QA, you see the activities we can provide, as Apave provide, independent third-party inspection, regulatory inspection, technical assistance, but also quality assurance activities. Also, we have quality control activities that we provide. And of course, this has an impact on the strategy and risk mitigation. And let Manish to.
Yes. As we mentioned before, the role of AIA is more than just doing product inspection. The role of AIA is basically starts right from the inception to completion. Basically, AIA will help you to make sure that you meet the requirements of applicable regulations and also help you identify the problems at early stages, before even they become catastrophic or sometimes before even they occur. And to do this, the AIA's involvement starts from the defining quality system to ensuring the work procedures are correct and performing physical inspection of the products and final inspection. Thank you.
So also the regulatory bodies, as in USA or in Europe, helps on the traceability of documentation. For example, regarding quality completeness and all the operation performed by the licensee or the subcontractor. And also it helps to manage the risk on possible CFSI or any other misunderstanding, we can say, on the project. So do not forget that the independent agencies, whatever the name, are here to follow the activity regarding the regulation, but also to help to mitigate difficulties on the project. Even they are technical, fully technical according to RCC code or ASME code, but also regarding the regulation. Do not hesitate to ask, even it is not related to regulation, some help from the bodies, even for technical assistance training or any inspection or control, even they are not mandatory by the regulation. As you understood, many activities related to nuclear are not mandatory. They are contractual. Remember the beginning of the bottom of the pyramid. So I think it's finished just in time. So do not hesitate to ask us for something on our booth from Apave N64, if I remember well. So do not hesitate, and you have our name. You can find us easily in LinkedIn or in person in the booth or just here. Thank you very much.
Thank you very much.